Okay, in our last one, we solved for 1 second to getting to the peak height. Now the next question is, what is the peak height? You know, how high is this after 1 second? So all we need to do is calculate the distance that this travels in 1 second from this point to this point. Now, in order to do that, we have to account for the fact that it has an initial velocity and the fact that it travels for 1 second, and it also has an acceleration due to gravity in the negative y direction. So the equation that we have to do that, and I'm going to recreate it on the next page. The equation is x final is equal to x initial plus the initial velocity times the time plus at squared over 2. And we know that the final distance is what we're trying to find here. This is the peak height. I'm calling it x, but really I could call it y. It's just a placeholder. So maybe to be consistent, I say y final is y initial plus v initial in the y direction times time plus a over 2 t squared, another way of writing that. And now we know that the initial height is 0 because the way that I've drawn the axis, the ball leaves y equals 0 plus y, and this is 20 meters per second. You might recognize this as well, we already know this is equal to this one here, initial velocity in the y direction. We calculated that in the last one is equal to sine 30 times 20 meters per second, or is equal to 10 meters per second. And so we've got that the final height, y final, is equal to 0 plus 10 meters per second times the time of flight, which is 1 second, plus negative 10 over 2 meters per second squared times 1 second squared. So let's kind of make sure we take care of the units. Second squared here, 1 second squared here. Seconds drops out. Our answer, it should be in meters. That's what we have left. That's what we're expecting. So what we see here is that y final is equal to 10 meters minus 5. Is that right? 10 over 2 is 5. So minus 5 meters equals 5 meters. Equals y final. Does that make sense? It's that for 1 second, starting out 10 meters per second squared, takes a second. So 5 meters is reasonable. If we had an answer like 50 meters, we would say to ourselves, that doesn't sound right. In 1 second, how is it going to go 50 meters? So this is kind of a self-check. Does 5 meters per second make sense? It does make sense for a height that it might travel.